Hello kids, I hope you're doing great. I am recording this video because there are some stage 2 topics of the science of motion subject that we won't be able to see during these last dates before the exam, before the midterm exam. So I will explain it. I will explain them to you. The last topic we saw was acceleration. And the next one is force kinematics and Newton laws. Previously, we have discussed how to measure motion independently of the causes that can generate this motion. This is called kinematics, but we want to study the causes of the motion. We use this part of the physics studies, which is called dynamics. There are there is an infinite number of possibilities that can cause a motion. But don't worry because Newton laws are here to save us and they can provide us a better understanding of how the motion happens. The first concept that we must be aware of the concept of inertia. The inertia is the capability of an object in motion to resist to a change. It can be an object in motion or an object in rest. The inertia can be expressed as the resistance to move or to stop. If we can see this first GIF, we can see a giraffe that I suppose she's driving a car and goes she goes she goes until she crashes with this wall. The car is exerting a force in the right way, and the wall exerts an opposite force that can overcome the car force. Therefore, the car will stop. It's the same situation in this GIF in which this woman falls down because this force oh, this force could overcome this another one. Inertia is highly related to mass. The strength of inertia is dependent of the mass of a body. The more mass an object has, the more difficult it will be to either move or stop the object. To overcome inertia, you need to apply sufficient force to overcome the inertia. Remember, inertia is the resistance to move or to stop. It's the resistance to change. What is a force? In simple terms, forces are a push or a pull exerted of an object resulting from its interaction with another object. During the last stage and the second stage, we have been talking about the vector or scalar quantities. The force is a vector quantity. This means that it has both magnitude and direction. Therefore, an example of a vector force could be minus. So I don't know why my pen turns that shape, but okay, 5 newtons, 5 newtons to the north, to the right, etc. Which is our magnitude, the 5 newtons. In this case, this force is applied is in a positive way. If it has a negative sign, this means that this force is going to the another side, to the opposite side, as we can see it in this image. Let me erase this because I don't like it. Okay. Forces cause objects to accelerate, change speed, which is the same as acceleration, change direction, or change shape. it could be a weird example, but you really like a lot those toys that are called squishies because you like to squeeze them, okay? As this squishy earth squishy that we can see in this GIF. Why does the squishy change its form? Because you are applying a force. You are applying a force with your hand. The force is measured in newtons. The newtons are a derived quantity which are composed from kilograms. Remember, the kilograms are the base unit of mass, and meters per second square, which is the base unit of acceleration. Therefore, the force formula is force equal mass times acceleration. Okay, there are three main types of forces, which are gravitational forces, the ones that maintain us on Earth, electromagnetic forces, and nuclear forces. There are three Newton's laws. The first one is the law of inertia, which statement says that an object at rest remains at rest as long as no net force acts on it. What does net force means? What does net force mean? Sorry, is the sum of all forces of an object. Okay, if our object is at rest or if it is moving at a constant velocity, this means that there is not net force applied to the object. Okay, but if our object has an acceleration, this means that this net force is different than zero. Okay, if this net force is zero, it explains that is the object is experimenting a state of equilibrium, which could be rest, or kinematic equilibrium, which is constant motion. I will show you how does it works using a simulator. Okay. Okay, let me show you how net force works. Okay, here we have this card, and I can use these little people to push or pull the card to whether both of the sides, left or right. Okay, let me show you the sum of forces, the values, and the speed is not necessary. Okay, here you can see that both of the guys are have the same force, are exerting the same force, which are 50 newtons. Therefore, the sum of forces is zero. Why is it zero? Because we have 50 newtons to the right side, which are counteracted by the 50 newtons that are applied to the left side. As you can see, the card doesn't move because the same force is being applied to both sides. But if I apply a 100 newton force to the left side, let's see what it happens. A net force is being applied, a 50 newton net force is being applied to the left side. Therefore, the card goes to the left side. But if I apply 150 newtons to the right side and 100 newtons to the left side, we have a net force of 50 newtons to the right. A 50 newtons force to the right. Okay. As I will explain you, when the net force is different than zero, which is the same thing is happening in this simulation, we are experimenting an acceleration. But if we don't, if we have a zero net force, if our net force is zero, let me change it. The car remains at rest. And if I apply a net force to one of the sides, it will move to the corresponding side, which could be left or right. When we have a zero net force, this means that there's no change in velocity. The object can be maintained at rest or at a constant velocity. There is the Newton's second law. The Newton's second law is the only one that is represented through mathematical formula, which is force equals mass times acceleration. Okay, forces are related to both quantities. The more mass an object has, the greater the force it needs to move. This says that the force and mass are directly proportional, and the more force you apply, the bigger the acceleration. Okay. Remember that force is a vector quantity, so it can move in any direction you want. In this part, we have sum of x component forces equals mass times acceleration in the x-axis. And then we have sum of y forces, or forces in the y component, which is mass times acceleration in the y-axis. Here we have the ratio of proportion, which says that the mass is inversely proportional to acceleration and the force is directly proportional to acceleration. Let me show you this. Those concepts in the simulator. Okay, this is the same simulator we used some minutes ago. This is the net force, this is the motion, friction, or acceleration. I will use the acceleration simulator. I want to see the forces, the sum of forces, values, masses, speed, and acceleration. And I will disable the friction. The friction is something very neutral in our daily life, but in physics during second semester, we don't consider friction. We only solve these math problems, considering ideal conditions, okay? Where in which there's no air friction, floor friction, dirty, all of these things. Remember that we use the robots during these days and they cannot move in the appropriate way because the floor was dirty, or there was a lot of friction, or some of the parts are more, some of the floor parts were more rough. Okay, I have this 50 kilogram mass and I will apply, oh sorry, I didn't deactivate the force. Okay, I will apply an sorry, I will apply approximately 330 force, Newton's force. As you can see, it happened a change in acceleration. Let me apply it to the other side. I am applying the 186 Newton force, and our acceleration is negative. Why? Because it overcomes and it is going to the opposite side. As you can maybe see, you maybe notice that the applied force in the opposite way can overcome the force that causes to the object to stop and then moving again to the another side. Okay, but let me show you the proportion using different masses. I will use this 200 kilogram mass, and I will apply all the forces available, which are 500 newtons. And as you can see, the acceleration is 2.5 meter per second square. But when we were pushing this 50 kilograms mass, the acceleration can the value of acceleration is 10 meters per second square. Why? Because this mass is lower than the fridge mass. Even if I apply all my forces, the acceleration will be lower, which is 2.5 meters per second square. If I want to stop the motion of the fridge, I need to apply enough force to overcome the forces applied to the right side, okay? Until the acceleration is negative 2.0 to minus 2.5 meters per second square, and then it goes again. And this happens with all the things that we see during daily life. The last Newton law is the third one, action reaction. This statement says that forces act in pairs. For every force, there's another one equal in magnitude but opposite in direction. Let's imagine this man wants to punch this wall. When you punch any object, when you hit any object, the object also sends you a force in the opposite direction. You maybe notice that your hand or your feet, your leg, any part of your body that have been the part of the body that had been kicked hurts because the object also applied the same force you did, but opposite in direction. This person applies a force to the right side, and the wall applies the same force to the opposite side, which is the right one. Okay. Another example is when you are jumping on a trampoline. When you jump downwards, the moment in which you fall, you can jump again because the trampoline pushes you up. Is exerting a force that can make the person to go upwards. Okay,